Alright, so in this particular problem here, problem number 2, we are now going to draw the network. We are going to perform the mathematical calculations and we're going to fill up the table. Alright, so first thing that you're going to do, draw first a network diagram before you can complete this table here. Alright, so to draw that, this is how it looks like. It's a little bit complex, right? But the key here is that you just need to follow, okay? And again, if you're going to do that in manual, you may need to use it in pencil, okay? The key here is that draw the network from left to right, top to bottom, okay? In a given network diagram, there must be always a beginning activity and there must be always the last activities, okay? Alright, so in this particular case, A is the beginning activity, and then your activity B, C, and D follows your activity A. Alright, so again, when you do the calculation, you have to perform one at a time. Forward first, and then do the backward. Alright, so let's take a look at it. Alright, so for your activity A, it started 0 plus 2 is equal to 2. So that must be also the earliest start of your activity B, C, and D because they're all coming from your A. That's why you will notice here we have 2, 2, 2. And then 2 plus 7, that gives you 9. 2 plus 10, that gives you 12. And we have here 2 plus 4, that gives you 6. Alright, so as we move on to your activity E, that is only coming from your activity B. That's why you carry over your 9 here. Alright, and then your F is coming from your B and your C. Remember, you need to carry the maximum value. So here we have 9 and we have 12. That's the reason why you have here 12. 12 plus 5, that gives you 17. For your activity G, we have here coming from your activity D and your C. So whichever is the maximum, that's the value of the start, early start of your activity G. So in this case, it is 12. Alright, so let's go now to your activity J. J is only coming from your F. That's why we carry over your 17 here. Alright, and then your activity I is coming from your F and your G. So in this case here, choose the maximum between the two. That's why we have here 17 and 20. We carry over the 20. So we have here 20 plus 12. That gives you 32. Alright, for your H, that is only coming from your D. So you have here your 6 and that's your 6. Alright, for your activity K is coming from your E and your J. Consider the maximum. You have here 15 and you have here 22. That's the reason why you have here the 22 here. Your activity M is coming from your F and your H. So whichever is the maximum between the two, 15 and 17, that gives you here the 17. 17 plus 4, that gives you 21. Your activity L is coming from your G and your H. So whichever is the maximum between the two, 20 and 15, that's a value that you're going to carry over for the early start of activity L. So we have here 20 plus 6 is equal to 26. So we have here your activity N is coming from your K, M, and L. The early finish of activity K is 22 plus 5, 27. 17 plus 4, 21. We have here 20. And we have here plus 6, 26. Where is this number coming from? 32 here. Oh, we have here, this one here. Your N is coming from your I as well too. So whichever is the maximum, see this connection here, it is connected to your N. So there are 4 lines, 1, 2, 3, 4. and whichever gives you the maximum early finish with those 4 activities, that will be the early start of your activity M. So we have here 27, 21, 32, 26. The maximum is 32. That's the reason why you have here 32. So 32 plus 3, that will give you 35. So again, whatever is the early finish of the last activity, that is the duration of your project. So in this particular illustration here, the early finish of activity N is 35, which means the duration of the project is 35 days. Alright, so to perform the backward calculation, we have here now your 35. Bring that here, 35 minus 3, that gives you 32. Because activity K, M, I, and L are all coming from your N, they're all the same here, 32, 32, 32. So 32 minus 5, 27, 32 minus 4, 28, 32 minus 6, 26. Alright, so we have those. Value now, 27. Let's go to your E. E is coming from your K. That's the reason why we carry over your 27 here. Alright, your J. Your J is coming from your K. That's why we have here your 27 here. Alright, and then we have your I. I is coming from your N. That's why we have here your 32. Your H here is coming from your L. That's why we carry over your 26 here. Alright, move on to your F. F is coming from 3 different lines. To your J, to your M, to your I. Remember, when you perform the backward calculation, you have to carry over the minimum. So what's the minimum of your late start of your activity J, M, and I? So we have here 22, 28, 20. What is the minimum? It's 20. That's why you will notice here that on your F, you have here 20. 20 minus 5, 15. Alright, so let's move on to your H. H is coming from your M and your L. So you need to choose between 28 and 26. What is the minimum? 26. Alright, so let's move on to your G. G is coming from your I and coming from your L. Whichever is the minimum of the two, that's a value that you have here. So the choices are your I is 20 and your L is 26. So that's why we have here your 20. So 20 minus 8 is equal to 12. Alright, so let's move on to your B. B is coming from your E and your F. So whichever is the minimum. So we have here 21 and 15. So the minimum of those two is 15 here. 15 minus 7, that gives you 8. For your activity C, it's coming from your F and your G. So whichever is the minimum, 15 and 12, that's the value that you have here. 12 minus 10, that gives you 2. For your D, D is coming from your G and your H. Whichever is the minimum of the two, that's the value that you're going to put here. 12 minus 4, that gives you 8. 12 minus 10, that's 2. 15 minus 7, that gives you 8. Alright, let's move on to the last one now. Your A. A is coming from 3 different lines. This one here, that's B, that's C, and your D. We need to choose whichever is the minimum. 8, 2, 8. So the minimum here is 2. That's the reason why you have here the late finish of activity A is 2 minus 2, 0. And again, remember, in any given network diagram, there must always be a critical path. Alright, so how do we determine if a particular activity is critical? The top numbers and the bottom numbers are the same. Alright, let's take a look at them. Activity A, they have the same top and bottom. A is critical. Activity B, they don't have the same numbers at the top and the bottom. It is not critical. Activity C, they have the same numbers at the top and the bottom. That means C is critical. Activity D has the numbers having numbers that are not the same as the top and the bottom, so it is not a critical activities. Here, activity G, they have the same numbers. It is critical. Activity I, they have the same numbers. They are critical. Activity N, they have the same numbers at the top and the bottom. The other thing is that they should be connected from the first all the way to the last. So you will notice here A, C, G, I, F. They're all connected from the first all the way to the last activity. If you don't have that, your calculation is wrong. You may need to go back and redo your calculations. Once you perform the forward and the backward calculation, then you should be able to plug in now the ES, the EF, the LS, the LF. The next thing that we're going to calculate now are your TF and your FF. Alright, so how do we calculate those? Remember, I mentioned in the previous problem that for all those activities that are critical, the TF and the FF have 0 values. And that's the reason why your A, your C, your G, your I, and the N have 0 TF and FF. Take a look at here. Your A is a critical, C is a critical, G is a critical, I is a critical, N is a critical. So all those critical activities that are in the critical path, TF and FF are 0. So notice here, your A, TF, and FF 0, C 0, 0, G 0, 0, and your I 0, 0, and N 0 and 0. And one thing that I want you to keep in mind is that TF, okay, must always be greater than or equal to your FF. What does that mean? The pre-followed can never be greater than your TF. Take note of that. So TF must always be greater than or equal, or they're the same as your FF. But FF can never be greater than your TF. You have to keep that in mind. Alright, so how do we calculate now the TF? As we defined that at the beginning, the TF is the difference either on the late start minus the early start, or the late finish minus the early finish. Either of those two, it should give you the same number. If it didn't give you the same number, you mess up on your calculation. You may need to go back and recheck your calculation. Okay, there are two things here. Okay, you must always have a critical path. Alright, if you don't have critical path in a given network diagram, you mess up in your calculations. Go back and do again your calculation. The second one is a difference between the late start and the early start, and the late finish and the early finish must be the same. Okay, for those non-critical activities. Alright, let's take a look at that. The total flow of activity B is equal to the difference between your late start, which is 8, and the early start, which is 2. So 8 minus 2, that is 6. Let's take a look at here. So for your B, the total flow is 6. Take a look at that. Alright. Or the late finish minus the early finish. Again, the difference between these two and this one must always be the same. So 15 minus 9, 6. 8 minus 2, that's 6. If you don't have that, you're wrong. Okay, make sure that you have to recheck again your calculation. Alright, for your activity E, that is not a critical activity, so you should have a total float. So we have here 21 minus 9 or 27 minus 15, and that will give you for your activity E, that is 12. Okay, so the TF, that is 21 minus 9, that is 12, or 27 minus 15, that is 12. Alright, so what's the total float of activity F? F is not a critical activity. So 15 minus 12, okay, or 20 minus 17. And both of them are 3. So 15 minus 12, 3. 20 minus 17, 3. That's why for your F, you have here 3. Alright? Alright, for your activity D, it's not a critical activity. So 8 minus 2, 6. 12 minus 6, that is 6. So they're the same. Take a look at here. Your D, that is your 6. Alright, so that is how you calculate the total float of a given activity. Okay, the total float is available for those who are not critical activities. In this case here, you must have total float for your B, your E, your F, your D, your H, your J, your K, your M, and your L. So those are the activities that has the total float. Again, how do we calculate the total float? It is just the difference between the bottom value minus the top value. 8 minus 2. Alright, so that is how you calculate your TF. And by the way, it explained that at the bottom and the note page in each of these slides. Okay, you will notice, class, that for most of your lecture in the PowerPoint, you have an explanation at the bottom. So you may need to look at that, or you need to look at the supplementary documents, because I also provide some explanation in step by step on those calculation. Alright, so next thing you have to do now is how do you calculate the free float. Alright, so let me show you the diagram. Remember again, the TF and the FF of the critical activities have a 0 TF and FF. Alright, so only those critical non-critical activities that has the TF and the FF. Alright, let's take a look at activity B. Activity B is not critical. So what is our formula for a total float for non-critical activities? The formula to determine the pre-float is the minimum of the early start of succeeding activities minus the early finish of the activity in question. So how is that? B is the activity in question. It is the minimum of the early start of the succeeding activities. What are the succeeding activities of B? Is your E and your F. Whatever is the minimum early start of the succeeding activity, that's a value that we are going to use to subtract to the early finish of the activity in question. So here, the early start of activity E is 9, and the early start of activity F is 12. So whichever that gives you the minimum early start, that's a value that we are going to consider. So in this case here, the minimum is 9. So 9 minus 9, the free float is 0. That's the reason why for your activity B here, free float is 0. You got it? Alright, so let's see F. F is a non-critical activity. So it is coming from activity J, M, and I. Whichever is the minimum of the early start of those activity, that is a value that we're going to use to subtract that to the early finish of the activity F. That is the activity in question. The minimum of those is 17, 17, and 20. Which one is the minimum? It's 17. So 17 minus 17, that means your F has a free float of 0. Your F has a free float of 0. Let's take a look at your E. Your E here is coming from your K. There's only one link here. So your E and your K. So early start of activity K, which is 22, minus the early finish of the activity in question. So 22 minus 15, that is 7. And that's the reason why the free float of activity E is 7. And do the same thing also to the rest. So you have to go them one by one of each of those non-critical activity for you to figure out the total float and the free float. Again, I want to remind you, okay, there are several rules here. When you draw the network diagram, you have to begin from left to right, okay? And then you have to follow the alphabetical letters, left to right, top to bottom, okay? The next thing you have to do now is to perform the forward and the backward calculations. As you perform the forward, carry over the maximum. Whatever the last number on the last activity, that tells you the durations of the given project, and then whatever the early finish of the last activity, that is also the late finish of the last activity, and then move backward to do the calculation. And as you move the calculations backward, consider the minimum. Okay, again, you have to calculate the forward and the backward one at a time. You need to complete first the forward, and then you have to do now the backward. The next thing is that in every given network diagram, there must always be a critical path. So how do you determine if a particular activity is critical? The numbers at the top and at the bottom are the same. Alright. The next thing you have to keep in mind is that the total float and the free float. For every given critical activities, the TF and the FF are zeros for the critical activities. Alright, and the last one, the free float can never be greater than the TF, which means that TF must always be greater than or equal to your FF. If you have a number in your FF that's greater than your TF, you're wrong. You may need to go back and check that again. They can be the same, but the FF can never be greater than your TF. Alright, let's take a look at the next problem here. This time, we have the lags. So what do you mean by lags? For this particular problem, problem number 3, it gives you a lag time. What is a lag time? The lag time, it is the amount of time that we delay the start of any succeeding activities. Do we have that in actual? Yes, definitely. Say for example, for concrete, for this slab, once we pour the concrete, we cannot build right away the wall framing. We need to wait a certain period of time until the concrete has hardened. The time to wait until the concrete has hardened is what we call the lag time. So that's where we are going to use the lag time in actual. Alright, so again, what is a lag time? A lag time is the amount of time that we need to wait before we can start any succeeding activity. Alright, so in this particular case here, you will notice that activity A is the starting. There's no immediate preceding activity. So you will notice here that there is a lag time between your D and your A. which means that we need to wait 4 days before we can start your activity D. And then for your activity F, the connection between your F and D has a lag time of 3. C is also linked to your F, but there is no lag time, okay? And then we have your G, your I, between the connections of, this is supposed to be, let me see, H. This should be H. Alright guys, this should be H. The connection between your I, this is your H, okay? That is H, that's not I, it's 1 day. So here, your H and your I has 1 day. Alright, so again, this H here, this I here should be your H. Alright, so just draw the network diagram. So again, you have here now your A is the start, B follows your A, C follows your A, and your D follows your A here. So take a look at here. All your B, your C, and your D, they follow your A here, and your E follows your B, and your F follows your B and C. So when you draw that up, you will notice here now your F follows your B and your C, and your G follows your C and your D. And take note, don't forget to put the link between your A and your D having a lifetime of 4. So where is that at? So here, your D and your A has a lifetime of your 4. Okay? Alright, so that's why you have here your D, A, and D, and we have here your B and F has a lifetime of 3, and your H and I has a lifetime of 1. Alright, so again, once you draw the network diagram, and one thing that I want to point out here is that when you draw the network diagram, connect this finish to start, because in most cases, as you've learned that at the fundamentals of network diagramming, there are several relationships in a given activities, and in most cases we have the finish to start relationship. We have also the finish to finish, start to start, or the start to finish relationship. But in most cases it is a finish to start. So that's why when you draw the network diagram, we have here the finish to start. Okay, so make sure that you put also the arrow, because that helps you as you do your forward and the backward. It helps you in the directions. Alright, so perform now the forward. So 0 plus 2 equal to 2. Carry over 2 plus 6, that's your 8. Carry over your 2 here. 2 plus 10 equals to 12. 2 plus 4, don't forget, right? That's the lag time. So you have to carry and add that 4. So that's why you will notice as your D, you have here 6. 2 plus 4 equals to 6. Alright, so 6 plus 4, 10. Alright, your E is coming from your B. There's only one arrow, so that's why you carry over your 8 here. Alright, and your F here, you're coming from 2, your C and your B. But let's take a look at here. 8 plus 3, that is 11. And you have here 12. Remember, when you move forward, carry over the maximum. So in this case here, you will choose between 12 and 11. 8 plus 3, that's 11. So which one is the maximum between the two? It is 12. That is the 12 here. Alright, for your G, G is coming from your C and your D. Maximum between the two, 12 and your 10. And that's why we have here the 12. Alright, that's why we have here now 8 plus 7, 15. 12 plus 5, 17. 12 plus 3, 15. Alright, and then your H is coming from your E and your F. Carry whatever the maximum. 17 plus 15. 17 and 15. Maximum is 17. Alright, and then when you move to your I, take note of this one here. 22 plus 1, that is 23. and we need to choose that between 15 and 23. That's why we have here 23. 23 plus 2, 25. In this particular project here, the duration is 25. So whatever this value here, that is a value at the bottom here. And then perform the backward calculation. And as you perform the backward calculation, don't forget to deduct also the lag time. So in this case here, 23 minus 1, 22. 22 minus 5, 17. 23, 23 here. There's no lag time. So your activity E is carry over this 12 here. Carry over this 12 here. And then we have here your 23 here. Alright? And then move on to your B. B is coming from your E and your F. So you have here 10. And we have here 12 minus 3. How much is that? That is 9. So you have to choose between 9 and 10. So that's why we have here 9 here. Your C is coming from your F and your G. Carry over whichever is the minimum of the two. 12 and 20. That's why we have here your 12. Your D here, carry over this 12 here. And that's where you have your 12. Alright, so that is how you calculate the value. And one thing that I want to emphasize here again is that in any given network diagram, you must always have a critical path. So in this case here, A is a critical path because the top and the bottom numbers are the same. C is a critical, F is a critical, H is a critical, and I. They must be connected all the way to the end. Alright, so activity A, C, F, H, and I, all the TF and the FF are zeros. The only thing they have to calculate now, those non-critical. So here on your B, your total float is 3 minus 2 or 9 minus 8. Alright, and then for your total float, you have to choose between the minimum. So we have here 8 and 12. So minimum is 8. 8 minus 8, that is 0. Alright, so H is critical. So total float is 0 because 23 minus 1, 22 minus 22, that is 0. So that is how you calculate all the values. So again, plug in those numbers into your table. And there you go. And one thing I want to emphasize again is that your TF must always be lower than or equal to your TF. Never that you have an FF that's greater than your TF. If you have that, go back and check your calculations. Alright guys, so that is how you perform the forward and the backward calculations. And if you have any question, send me an email. You have the supplementary documents. It helps you figure out, again, those numbers. If you miss some of those steps, you can always go back to the video or you can look back into the supplementary documents. Alright guys, that is it for now. And if you have any questions, just send me an email.